Okay, so now we are going to discuss about the concept of the centripetal acceleration, right? Now, if someone asks you about that, why acceleration is produced in a circular path when speed is constant, so are you able to answer that question? If the speed is constant in a circular motion, so why acceleration will produce in circular motion? So are you able to answer
because
that
of
one now? Hmm?
because of changing direction.
Yes, because of the continuously changing direction of the velocity, right? You may note down
Yes.
after the class because I will share this PDF file with you. So just
Okay.
follow this green line that to the complete description, right?
Okay.
So we already discussed about the consequence that why centripetal acceleration will produce over there. So we are not going to discuss that again and again. So for centripetal acceleration, we know that the body is moving with constant speed with changing velocity or the direction. Okay, and the centripetal acceleration is always perpendicular. So it is always perpendicular to the direction of, you can identify from the diagram that it is completely perpendicular to what? The linear speed, right? It's v.
Yes.
So it is always perpendicular to the linear speed. Because sometimes they ask about the direction also, so you can identify from the diagram that the direction of centripetal acceleration is always towards the center with the direction of force, because we know that force and acceleration both are directly proportional, both are vector quantities, so that's why they both will act in the same direction, right?
Yes.
I will also write down that point. So centripetal acceleration and the centripetal force both will act in the same direction, that is towards the center of the circle. Clear? So this is the concept, right?
Yes.
And we know that centripetal acceleration will produce with the help of centripetal force, because once we applied the force, so then acceleration will produce, otherwise there will be no acceleration. So centripetal acceleration can be produced with the help of centripetal force, right?
Yes.
And we know that centripetal force will be a constant because when we start and then we just compare, so centripetal force will also remains constant because body or the motion of the body is with constant speed, right?
Yes.
Okay, so this is the concept, and you know that if we write the formula, so the formula for centripetal acceleration is AC, that is for centripetal acceleration, is equals to v square over r. So this is the concept of centripetal acceleration or the formula for centripetal acceleration, right? And next we need to also discuss that how this formula derive from the basics, or if we want to compare the uniform acceleration with the angular speed. So that is also a concept to discuss, that how they will compare with the each other, right? So let's suppose if we want to talk about the formula, so we know that if we want to calculate the centripetal acceleration, so we will calculate like this. So first of all, if someone asks you about the definition of centripetal acceleration, so you may also define it as that the acceleration of an object, the acceleration of an object towards the center of a circle when an object is moving around a circle at constant speed. Because each mark is important in AS, because that will give you a help in your A2. So that's why never take anything simple and light in your AS. So this definition will also give you 1 mark, because mostly they ask about define centripetal acceleration, define radians, define degree, define angular speed, anything they used to ask before the question for 1 or 2 marks sometimes. So try to take each and every mass, that is very simple to take. So this is the basic definition of centripetal acceleration again, if you want to write. And then we are having a graphical or complete picture representation of angular speed with the linear speed, with the centripetal acceleration and the radius, right? So let's suppose we already write the formula for the centripetal acceleration, that is AC is equals to V square over R. So this is the basic formula that we already discussed in IGCSE, but we never solve questions related to that. And we already drive one more quantity, that is the relation between linear speed and the angular speed. That is V is equals to R omega. In this chapter, we are having more mathematical concept, because that is related to circle. So that's why there are mostly derivation parts and less theoretical concept. Okay, so don't get confused in it, because this chapter is slightly different from the other. Okay, so now we have two equations, right? One is AC is equals to V square over R, second one is V is equals to R omega. Let's suppose if we want to substitute the value of equation 2 in equation 1, so your equation 1 will be equal to AC is equals to V square, sorry, on the place of V we need to write R omega whole square, right? And after cancel out the value of R with the R in denominator, your final answer will be equal to AC is equals to R omega square, right? Clear? Any confusion?
No.
Okay. And one more thing, if you remember, we also write as that your angular velocity, sorry, your angular speed is equals to V over R, right? Remember that?
Yes.
So if we use that concept and we just shuffle these values like this, R is equals to omega, right? So we can also substitute this value that v over omega in equation number 3. Okay.
Okay.
So that will give you what value? Uh, just take the reference from the first equation, that is AC is equals to V square over R. And if we substitute this value over here at the place of R, so this will be equal to V square over V over omega, right?
Yes.
And if we flip the values, so you will get, and your final answer, V omega, right? So basically, there are two alternative equations that can be that we can use for centripetal acceleration with angular speed, right? This equation gives you the concept of centripetal acceleration with linear speed, and these two equations, this one, equation number 3, and equation number 4 gives you the concept of centripetal acceleration with angular speed, right? Clear?
Yes.
Basically both are the same. It's up to you that from which concept you are driving the equation, right? I'm driving both equations because when we are solving the questions, so sometimes they just give you the same question that drive or just find the value of AC in terms of V and omega, right? So you already know that how to drive that equation, because in this chapter or from this chapter we are having multiple questions in our past papers on the same theme to drive the formula, right? Or to drive the equation in terms of this or that. So that is the situation that why we are driving the questions like this. Okay.
Okay.
Any confusion?
So first, we will go from, I'm talking about the fourth one. So we
Uh,
have,
equation number 4.
yes. So
Okay.
we have AC is equal to V square
Over
over
R. Yes.
V over W,
V
the green one.
AC is equals to V square over R, right? And then we substitute the
Yes.
value of R, that is over here, V over omega in the
Yes.
denominator, right? And we are having V over omega. Okay. Any confusion?
Okay.
And then you know that
No.
if we are having two denominators, that denominator then an other denominator, so we just flip the values. So V omega will be flipped and that come into numerator like omega over V,
Okay.
this value. And this one V is cancel out from the other one. So one V is still there. So AC is equals to V omega. Basically, we need to take the reference from the basic formula. That is equation number 1. After that we are having two choice, right? Either we use go with this formula, that is equation 2, or the second option is go with equation number A. So basically these are two alternative methods, right, to drive two different formula, but that will make the same sense, right? Because in equation 3 you observe that R omega is square, right? But in AC we are having V omega, right? Because in V there is already a concept of distance over time. But in AC, that in equation 3, we are only having R that gives you only the radius, right? So omega square gives you the two components of the speed, right?
Yes.
Because both are like in the same direction, because both are rotating in the same direction. So that's why in equation 3, we are having omega square. If we take reference with the R, and if we take reference with V, so we just write angular speed into linear speed, right?
Yes.
Any confusion?
No, up till now, no.
Okay, because they never ask about the theoretical background or the conceptual background in your exam, but you need to know about the derivative part, right? So that's why we are talking about the derivative part, because that is important. And when in next class we try to solve questions from past papers, so you will find that these questions are completely copy pasted in your exams, right?
Okay.
And you know that if you know the value of acceleration, so centripetal force is not much very difficult to calculate, right? Because you know that force is equals to ma, right, from Newton's second law.
Yes.
So if we talk about the centripetal force, so basically centripetal force is the force that actually keeps the body in a circular path, right? So again, the definition for 1 mark, we need to write the resultant force towards the center of the circle required to keep a body in uniform circular motion, right? So it is always directed towards the center. We already know about that. We already observe in different diagrams, right?
Yes.
Okay. So you know basically that F is equals to MA. So if we start from that concept, so let's write FC. Centripetal force is equals to MA. AC is centripetal acceleration. So we know that acceleration or centripetal acceleration is equals to V square over R. Again, equation number 1, right? Remember that?
Yes.
If we replace over here, V square over R, and your final equation will be equal to mv square over R, right? It's one possibility, but let's suppose if we again just drive another formula, because you know that derivation is now very much important. Okay, so basically, we are talking about the formula. Let's suppose if we ask, because they will ask the question like this, that in terms of this or that, drive the formula of this, right? So basically, there is a concept, right? So basically, FC is equals to mv square over R. But let's suppose if we consider another equation, again, V is equals to R omega, right? So this V is equals to R omega gives you the value of, if we substitute in equation A, so FC will be equals to R omega whole square divided by R, right? So we can just multiply or divide the terms that are actually cancel out each other. So that will be equal to, so your final option will be, mr omega square, right? Clear? This is the second formula that we can derive from the basics of centripetal force and the basic concept of v is equals to r omega, right? Clear? Any confusion?
Um,
Okay. Okay, just one more thing. Okay, we drive r omega square. Okay. So this is how you can see that we can drive different quantities by just substituting the one equation into another, because we know that by using Newton's second law of force is directly proportional to acceleration. So that's why both will have same value and same direction. And one last thing that we need to discuss, that Fc is actually centripetal force, and we know the SI unit of force is always Newton, right? And secondly, we are having V. V is your linear speed. So that will be always equals to meter per second. And next we have omega. Omega is angular speed. And what is the SI unit? We already discussed.
radians per second.
Yes. Radians per second. And then we are having R. R is simply the radius of orbit. And this will be equals to meter. Okay, clear?
Yes.
Any confusion?
No.
Okay. So these are some basic concept, basic equations that are related to this circular motion. Okay. Uh, because this concept is connected with the other concepts or other chapters, we can say that, because next chapter is related to the gravitation. And you know that when we were talking about the planets, so there will also a circular path or a uniform circular motion of the planets. So this equation or this concept will also help you to find out the value or to uh, find out the concept, right?
Yes.
Okay.
Okay.